about this very cool topic today.
Awesome. Like, I'm excited for this. Let's go. Let's get it.
All right. Well, I guess good morning for those of you on the East Coast. My name is Adam Kaplan. I'm the team lead for the Openshift Build API team. We are in charge of the Openshift Build system. And today I'll be talking a little bit about my history of building applications, and hopefully this is might be entertaining for some of you on the Twitch stream or the TV stream. I'll then talk a bit about Openshift Builds and the evolution of that with this new project called Project Shipwright.
Cool.
So I want folks to kind of maybe think back 10 years ago. How were you building your applications? What did it take for you to get your code into production? For me, I was a software engineer at a small bespoke software firm. We made software for clients, usually in the transportation and financial sectors. And my team, I was in a small group. There were 3 other engineers, and we wrote our code in Java. We tended to compile our application jars on our laptops using Eclipse, and then we would deploy them directly to our test servers. And since we were a consulting company, we were working with clients when we had to actually release our software. We'd upload these jars into a zip file. We'd ship them over via usually an SFTP server, fill out a bunch of tickets and change orders and whatnot. And at one point, the project manager made us be the ones to fill out those change orders.
Nice.
And then finally, it would be handed over to their IT team, and they would be the ones to release it out into production.
That sounds very, stereotypical for old school setups.
Yep.
No offense if that's your current setup now, but
no
SFTP is quite long in the tooth.
But it works.
It works.
It
does work.
And digital transformation is not easy.
No.
I remember one point, so my team was small. There was another team that was a little bit bigger. There were about, I want to say 15 or so engineers, and they had a shared code base with other ones. And they stood up in the company meeting, and they were excited to debut this new system they were using for continuous integration called Hudson. And that was
brand new, huh?
It was
brand
new
new hotness.
Yeah.
Hudson.
That shows you.
Yes, that shows you where we were.
Right, exactly. Yeah.
So next slide, Shubik. So I want to flash forward then to about 4 years ago. I had moved on from that software firm to a startup that was building a mobile application. And so our backend was a Django Python backend. And we were deploying to Amazon EC2. And that setup worked, okay. Releases were, instead of building a jar, we just had a script on our AMIs that would just check out the code from our production branch and then deploy the Django migration scripts, and then we were good to go. But the CTO approached us, who was a friend of mine who brought me onto the company, and introduced Kubernetes, which at that point was version 1.3, in part to deal with some of our scaling problems, but he thought it could also help us out with actually shipping code. So that first challenge that I had and our team had was to learn how to assemble this application the way that Kubernetes understands it, which is the container image. That old process of just checking out our Python code directly onto our EC2 instances just wouldn't cut it out. So Shubik, next slide. So along the way, we had to learn all the new tools of the trade. So we had to thrust ourselves into Docker. We had started writing our own Docker files. We were using Circle CI at the time, so we extended that to build the container images on our CI. We would then push that to a private Amazon container registry that we had set up. And then we would go ahead and deploy that onto our Kubernetes clusters we actually had YAML templates in our Git repository. So even before GitOps was in our vernacular, we were already doing that, and
Yeah.
it was awesome. We were so proud of that system once it.
I bet. Yeah, that was good stuff.
But getting that into production was actually not easy. We had several failed attempts to get it out there. We would have, we try to deploy, month later fails, month later fails. I think it might have been it took us 6 months to actually get it fully hardened and out there in production. And so I really wish that we had known about Openshift when we did that. So with Openshift, as first off, I hope folks on the stream know about Openshift and Openshift Builds. Because if they don't, it is a...
If they don't, I bet we have somebody on the call that can tell them
Yes.
about it.
Yes.
I would just like to say that Openshift builds are a major distinction between Openshift and vanilla Kubernetes in some regards. Not very many Kubernetes platforms run their builds on the platform. Usually these builds are processed externally via some other system. It might be Jenkins or something else. More and more common, you have Jenkins X and these newer style build systems that are running on Kubernetes. But then the security model can be kind of tricky. Often running these builds introduces root context and elevated privileges. And so you may not want to run builds on behalf of other users if you don't trust them. So there's a whole lot of security stuff that comes into play when you decide to run builds in a multi-tenant system. And so this stuff is not just builds, it's like layers of security expertise combined as well. So this is really interesting stuff if you look at it from comparing what's available in Openshift versus vanilla upstream. You can do a lot of these similar things in upstream, but with some added security risk. So
Right.
Yeah,
I think to add to that, usually outside the context of OpenShift, folks consider building images something that you do outside the cluster and then you just deploy it on the cluster, which is where OpenShift Builds has been very differentiating with our OpenShift offering in general. Back to you, Hat.
Yeah. And it's a good point, Ryan, that you bring up security, because most things that are assembling a container need at least to be running as root inside the container. Which for folks who have done work with OpenShift know that can actually be a challenge. You don't get that by default. Usually you have to provide some additional privilege to your workloads if you want them to run, or you need them to run as root. OpenShift in the 3x and even the 4x days took care of that. It knows that builds are a sort of trusted system that can run your build workloads, and because of that, the build system is fairly locked down. There are two sort of main strategies you can employ with Openshift builds, and I wish I knew this back then. You could use the sort of Docker strategy, which is where you provide a Docker file, and Openshift will create a container image from your Docker file. And then there's also the source strategy, where you don't need the Docker file. Openshift takes care of the packaging it via the source to image tool and the source to image ecosystem of builder images that Red Hat provides and maintains.
Yeah, and I think that's a good point to take a little deeper look into what we're actually doing in Openshift as in terms of builds. Generally, those builds may not be installing RPMs into the image. Usually, there's some amount of kind of standardization that your team lead or your security team or someone may have done to produce kind of a base system image, and then average developers are often running a build on a system image that's been kind of provided. Red Hat provides a good stock of these images, but your team lead or your security team could potentially extend those images in some way, upload them back into your OpenShift system, and then you could run this type of build process on an extended image instead. So there are still ways to extend these. It just takes some extra effort.
Absolutely.
But that's generally the pattern everyone's going to follow. Anytime they're running an application build, they're rarely starting from a scratch image. They're often using something like, at minimum, an Alpine image, but they're picking something that's off the shelf to work with. So we follow that type of pattern for app builds.
Right. And certainly for thinking back to my days at this startup, if we were going to deploy it on OpenShift, we would have likely used the Python image that's provided by Software Collections. It's available as what's called an image stream on OpenShift, which basically gives you a shorthand to point you to those container images, which are actually, they reside on Quay and Docker Hub, but they also, when you install OpenShift, it's available on the container registry that lives in the cluster as well. So you don't even have to go out of the cluster to get your base build image. And with cluster admins, security teams who want to extend those images or create their own, they can create those image streams with those more hardened or more specialized base images for their builds, and then share them through OpenShift image stream. So it's a very powerful part of the OpenShift developer experience and CI system, if you will. So, are there any other questions out there before I move on a bit?
Thanks for asking. We don't have anything in chat quite yet, but yeah, good content so far. This is particularly showing Java examples. I was just going to comment 10 years ago, I don't even know if I really ran builds as much. I mostly just checked in my source code, and the release team maybe had Hudson or Jenkins and maybe something else downstream from me. But as a web dev, builds wasn't even something I necessarily had a concept for. So yeah, major changes in the last 10 years.
Yeah, that's a good point. That, you know, when I was doing this, since we were a small company, we didn't necessarily have a release team that was in charge of assembling the code for us. But we had a far worse case where most of the time we were building the code just on our laptops and then shipping whatever artifacts that were on our laptops. We didn't have a trusted system to do the build for us. With OpenShift, you get that out of the box where it can be your trusted system for providing the artifacts that you can deliver to your customers, or you can deliver it to other teams within your organization.
Yeah. Also, I would like to add that maybe 10 years ago, we didn't have a way to resolve in a consistent way our dependency, right? We had to code, resolve the dependency locally, then build the artifact, ship the artifact. But setting up the environment was requiring maybe lots of time, and the environment weren't all the same, right? So it works on my computer. Now with containers, doesn't make any sense, because the container is the image, is portable, is the standardization of this process. And the importance of having a universal building system for building those containers, which are immutable, portable, across any environment. This is very powerful. And I think this tool will help us and will help developer on that also.
So I guess, Shubik,
Cool.
do we want to move on?
Yeah.
Yeah. So
Let's go ahead.
so we want to fast forward now to today. the thing that's really changed is the plethora of tooling that's out there to build container images, and more importantly, build these container images within a container itself. When OpenShift 3 came out, what the only option really was Docker. That's what OpenShift ran on. When OpenShift Builds ran, they actually they talked directly to the Docker socket, which is risky from a security standpoint. And so you can still do that today, but that is widely considered not a good practice when you're in production. So today we now have two very good options for building container images within a container itself. Builda, which Red Hat maintains, and Conoco, which Google maintains, if I'm not mistaken.
That's correct, yes.
Yeah.
There are tools to assemble code without the Docker file. So we have source to image and also cloud native build packs. A lot of people are starting to use cloud native build packs these days. They find it to be a very easy system to do to get you started making container images with no knowledge whatsoever. There's a lot of runtimes that different build pack providers support. For Docker itself, they've split out the building logic into BuildKit. And there's other tools like Jib that are more specialized for a specific programming language. I believe Jib is for Java, right, Shubik?
Yes, Jib is for Java.
Jib is for Java.
There's a lot of tools.
And
Well,
there
yeah, no, I
are many,
bet.
many more
That's
coming.
Yeah.
There's lots out there. I'm sure there will be more that come out either specialized for specific languages or take a different approach when it comes to security profile for building container images.
Yep.
And if you move on, Shubik, to the next slide, that is now where we on the Build API team are starting to see the limitations of what we had done. So when OpenShift Build started, Docker was the only option. We provided source to image as a way to ease development teams into creating container images. But it is very much a black box system. You only get what OpenShift provides. It's very difficult to extend this. There is an option in OpenShift called the custom strategy, but there you're kind of on your own. You have to, if you wanted to use build packs today on OpenShift, the only real way you can do that is to write your own custom build strategy using the base images provided by whatever build pack provider you're going to use, like Paquito or Heroku. You then have to get a deep understanding and knowledge of how those work inside of a container, what steps you need to run in order for you to create a container image. It's very difficult for any one organization to do. And especially if this is not an organization's like core competency, that's not what people in the company are supposed to do. If you want to ship software quickly, it's really not a good option. So we realized that we needed to take a different approach.
Yeah, I mean, users, customers, they should not be in the business of writing up tooling to do image builds with different strategies on their cluster. They're not in that business. They're trying to get stuff out for their customers,
Right.
be it in telecom, be it hospitality, whatever it is. But building images, that's not their business.
Yeah, like if you're in the image building business, cool. But like,
it's cool.
pretty sure
yeah,
your business
cool.
is not that.
For me, it's like for me, yes, it's great.
Yeah, exactly. Like it's cool for them, but nothing beyond that. But for us, of course, it's way more cooler.
Yeah, I used to write software for an airline, and that's not their job.
No,
Yeah.
no.
So with that, we decided to take a new approach, and we wanted to make this something that is open and flexible, and more importantly, can work on any Kubernetes distribution. And with that, we have Project Shipwright. So Shubik, you want to take it from here?
Yes, thank you very much, Adam. Hey everyone, I'm Shobhik. I work with Adam, and I'll quickly go over some of the what's of Project Shipwright. So Adam has done a great job giving the history of Openshift Builds and why we are here today, extending the whole build framework in a way that it can run on any Kubernetes. So yeah, so Project Shipwright is effectively a framework to let you build container images on Kubernetes with your build strategy of choice. The main reason that's important is that I, as a user, have heard that there is this new cool build strategy that is amazing, and I should not have to be a Kubernetes expert to be able to get that working because my company is not in that business. My organization is not in that business. So this project effectively lets you, it facilitates you to choose your build strategy of choice, your tool of choice, and be able to build a container image on Kubernetes. What that means is any Kubernetes, it could be Red Hat Kubernetes, or it could be any other vendor. That's totally fine. But it gives you that assurance that this has to work on not just OpenShift Kubernetes, but on any Kubernetes. And interestingly, this is powered by Tekton APIs under the hood. What that means is, like, a lot of people say, hey, we've got Tekton that can build images. I said, yes, it can build images, but Tekton is a general purpose API. It's like a Swiss knife. It can do a lot of things. But what the build project wants to do is it just wants to build images in an amazing way where you take care of caching, you take care of different layers on your own. You as a user should not have to be exposed to Tekton APIs for building images. That's a specialized task that Shipwright helps you do. And with that, I'll quickly show you how the APIs look like. So there are these 3 different APIs there. You've got the build strategy API. I mean, what else can it mean? It means it lets you define a new build strategy. There's an API called build, where you define what your build looks like. You see on the left. And there's this build run, which means that, hey, I've defined what my build looks like, and I want to execute an instance of a build, which is I want to run a build. So that's what build run is for. So these are 3 APIs we primarily expose. The goal is that we want to make sure that these APIs are simplistic enough. At the same time, they are powerful enough for you to build images with the same flexibility that we allowed today and the same flexibility that users would want to have when the question of different build strategies come into effect. So yeah, with that, I'll quickly jump into a live demo where we'll see how these work in action. So quick thing before we do that, and this is on installation.
We love live demos.
Awesome.
Live demos are the best.
Fantastic. You should not be disappointed. Let's put it that way.
Okay.
Right. So how do you install it in OpenShift? So it's an operator called Shipwright that you go to Operator Hub and you install it, and it should show up like this. And once you do that, it'll effectively tell you, it's got a nice description. It tells you how to get your favorite build strategies out there, and I'll show you them in a bit, and it gives you a nice information about how to get stuff running. So I'll quickly get into the demo. Before the demo, I think let's quickly go over how can we build images using which strategies. So if I go in here, I see there are these 3 build strategies that we have already on the cluster. You've got Builder, you've got build packs, and you've got Kaneko. So it's a nice diverse set of companies who've invested in these, diverse set of communities who've invested in these. And let's try to get a build done using build packs on OpenShift using Shipwright. How about that?
I like
Yeah,
that.
cool.
Let's do it.
Just one question. Is Builda the source to image?
No, this is Builda.
Kind of build? So
This
just
is
Builda. So
just Builda,
there's no source to image here.
In this screen, no.
Okay. Yeah.
So Builda is effectively, if a user goes to the Builda GitHub project, say, hey, I love Builda. How do I use pure Builda on OpenShift without having to know that S2I is a thing? This is basically a build strategy to use that Builda. And similar to Kaneko, let's say you've used Google Container Tools, you love Kaneko and you want to use Kaneko, this strategy exists here. Awesome.
Is Builda also capable of running S2I builds?
I'll get to it. How about that?
Okay.
Yeah, it's in my script. Let's go for it. Yeah. Awesome. So let's do build with build packs. I'm gonna go and define what a build looks like. So let's quickly start with some YAML for a change. So effectively, this is what your API looks like. So I can do a form view. Which, yeah, I'll stick with this. So effectively, you say, hey, I want to build this source code. I want to use a build pack strategy. And I want to push the image to, let's say, let me push it to something called somewhere in Quay, let's say demo Red Hat TV, for example. Let's say I want to build an image and push it here. And what's special about this is that I want to use the build pack strategy for this. Let's see how this goes out. So I'm going to start with defining the build. That doesn't necessarily mean it's going to run right now. Ouch. Okay.
There's an
Typical.
apostrophe
Here
at
we
the
go.
end.
Yeah.
Oh,
Yeah.
I love it.
There was a trailing apostrophe I saw
Right. Yeah,
That'll
this
do it.
in the
doesn't
YAML. Yeah.
start with again. Yeah.
Oh,
Run
yeah.
and compile with the eyes. It can compile syntax with the eye.
Yep. So what I've
That
done
worked.
is, yeah, that worked. I've effectively, let me go and modify this a bit. So we said the tag will be Red Hat TV, and I'm not going to disappoint you on that. So, yep, I have registered a build, and it says you registered true, which means I can now go and try to run it. So what I'm going to do is I'm going to go and try to run my build. So like I told you, it lets you go and create a build run. And yes, we're going to build experiences around this. So let's use a form here, right? So let's call it, my build run, my build execution. And I'm going to use a specific build that I created right now, which I call fruit app build. That's the build definition that we just created. And that's pretty much it. And so I just said, I just removed this, which I don't need. So I just said, I need a build execution using this build. And I say, go ahead and let's create it. So I go in here and it says, yeah, it's pending. So which means it's right now figuring out how to get this stuff running. It went to running. Awesome. So things are moving. Let's go and quickly take a look at some pod logs. The build is running. I can effectively, while your logs show up, you can see what it did for you behind the scenes if you were a Kubernetes nerd. It basically went and spun up a bunch of containers for you to go ahead and have your build running.
Wow. Is this Tekton doing this, all these containers,
Yes,
creating all
behind the
these containers?
scenes,
Right.
correct.
Okay.
Exactly. Yeah.
Good to know.
Cool.
So yeah, you could see that here are a bunch of container logs that are going to happen for each step. And you can see here, it basically says, hey, I'm building and I'm adding some layers to it. And then I'm going to push it. It says, oh, nice, it's completed. So I go here and I say, see, there's a successful build. So what we just did right now is we built an image using build packs on OpenShift using shipwright. And we pushed it to Quay using a very simplistic API, which just let you choose, here's what you want to build, here's your strategy, and here's what you want to push to, and that's it. So my build is done. So now I'm going to show you a few more interesting things. Right now, you've successfully run a build using build packs. Now that you've heard, hey, build packs is cool, but what about my S2I? I love my S2I. I've been doing that for a while. I hope you're not taking that away from me. I personally love S2I. So now let's go ahead and do the usual S2I things. So what I'm going to do is I'm going to do the same thing. I'm going to say, hey, let's create a build. Let's define a build. Let's call it something like, let's call it node app build. And I'm not going to lie, but I do enjoy pushing things to the internal image registry in OpenShift because it just removes all the trouble of going to have configure an external registry access. So I'm going to say, hey, With shipwrite, I'm going to do S2I, and I'm going to continue pushing to the internal registry so that if you're a lover of the internal registry image streams, nothing changes for you. So I'm going to do something like, let's say, push my image to the internal registry. And why not? So what are you going to build? I'm going to build software collections node application, let's say. I'm gonna use, and then since I chose S2I, if you're having deja vu, you know that you need to specify your builder image. So I just go ahead and choose the Node.js builder image. The API lets you do that. This is not a Docker file. Let's get rid of this. And you can see one more thing, which I'm not going to demo it, but you could potentially say, hey, after doing the build, here is my runtime base image. Put your artifacts in a lean UBI image if you want to. The API supports it out of the box. So you could do all that. So we filled out a bunch of forms. Let's look at the good old YAML view. So we've said that we want revision master of this repo to be built. We want it to be pushed to internal registry, which means you could do, of course, I showed you Query.io, but I'm going to show you internal registry now. And then this is what you're building. So, and hey, this is cluster. Let's just call it, oh, I think I missed a step. Yeah, so I think one thing which I didn't show you while I went on to do that is that, and you didn't even ask me that, that's not fair, that there is no S2I strategy here, right? How the heck I'm going to build S2I? So let's go and add the strategy. That's not too hard. So what I'm going to do is I'm going to say, hey, you know what? I'm not confident that I want to expose S2I to the whole cluster. Let's have a namespace scope strategy, because I want to try it out in my namespace. If I love S2I, I'm going to give it to the whole cluster. So let's use a build strategy that's only available in this namespace. I mean, previously, whatever you enabled was available to the whole namespace. Now you can choose a specific strategy for your own namespace only. And interestingly, if you see, this strategy uses the Red Hat supported S2I image as well. So this works with pulling stuff from Red Hat registry as well, without having to disrupt things that should not be disrupted. So awesome. I have my build strategy. I have 3 cluster build strategies, and I've added a build strategy called source to image Red Hat. And now I'm going to continue saying registering a build using that. So this is a build strategy. So to quickly recap, we said we want to build this Git source, push it to an internal registry like the good old days, and use the source to image Red Hat strategy using the upstream project. So that's a lot of information in a short sentence. Let's go and register it. So I registered the build. It says that, hey, your build definition looks great, which means now it's time to go ahead and run a build. So we've called this node app build. I'm going to do something very simple. I'm going to just say, hey, let's go to build run. Let's create a build run. And I want to run my node app build. I just give it a very basic name. And I say that it refers to a specific build definition. And that's it. I'm not going to say anything else. Again, in my YAML view, I'm just going to keep it very simple so that it's easier to convey what I'm saying. So yeah, I'm going to do a build run now for this using S2I. Let's see how that works out. Say spending.
So Subik, I don't mean to interrupt you, but we have questions in chat. Can I ask them?
This is
Adam might be able to answer them as we're going here. Does Shipwright support building from local? Does it support strategy detection, or you need to know upfront the strategy to use? What about security? Who controls where and how the builds run? What about concurrency, parallelism? There's a lot of questions here.
A lot here.
Ryan, help me.
All right. I can at least start with the building from local source. So that is something that we definitely want to support. We are working on a proposal right now to hammer out a command line interface. starting simple, but one of the main use cases we want with the command line is to eventually support building from local source and pushing it into your cluster to be built. So that is on our sort of roadmap. We want to make the command line available as a standalone binary as well as a kubectl plugin. So you can integrate it however you choose. Other questions around security. So I think right now, Shuba, correct me if I'm wrong, with the security stuff, because we're powered by Tekton, some of the build strategies define what security context they kind of they request it. Right now, Tekton is the thing that is gating whether or not those things can actually run.
Right, and to quickly add to that, right? So you can define a build strategy which does not ask for anything privileged. You can ask for a build strategy that asks for something privileged. So if you happen to be running on a Kubernetes cluster where they allow you to run privileged stuff, go do whatever you want, but then you have control over your build strategy, and you can basically modify your build strategy to say, hey, I don't want privilege, or hey, I want privilege. And if your cluster supports it, it'll just go ahead and do it. So potentially, what the build strategies API allows you to do is that it lets you choose build strategies that may or may not need those privileges. So we kind of democratize this bit to ensure that you choose the level of security you want. Of course, with Openshift Builds, when we ship it, we're gonna ship it, of course, with extreme levels of security. But if a vendor wants to take Shipwright and put it something on low privileged, that's the vendor's concern. But there's going to be recommendations in general to, of course, use as non-privileged as possible. Like the community is going to recommend that, but vendors can make the choices.
Yeah. So like, for instance, on the extreme end, in terms of relaxing security, if someone wanted to create a Docker build strategy that mounts in the Docker socket and runs itself in privileged mode.
Yeah, you can totally blow yourself up with that.
You can totally do that if you want.
There's nothing preventing you from doing that.
You can do the opposite and use something that doesn't even run as root. It could run as any UID. It only requires a certain level of SE Linux capabilities. You can totally do that too.
Right.
Super cool. So you could go anywhere from like fully locked down to fully build anything you want. All your dreams come true, anywhere in between.
Yes.
Awesome. I had one other question, and we can handle it later. It was more about architecturally, like there was a ton of screens you had that were showing a tab for like build run and a tab for like, there was a bunch of tabs in here inside Shipwright. And I was just surprised to see all of these tabs, all instances, build run, build strategy. This seems like a lot of UI for an operator to bring. And I would be curious to hear more about that whenever it fits into the presentation.
Sure, yeah. Sure, I can quickly address that. So this is so currently Shipwright doesn't have any OpenShift specific UI at all. So this is effectively us ensuring that the stuff the project does shows up fine on OpenShift, but there hasn't been any first class integration of Shipwright into OpenShift yet. So in other words,
I see all this under the builds tab or something, like integrated into the left. This is really cool to see an operator be able to provide all of this as a nested UI. It's really neat.
Yeah, I mean, from an OpenShift perspective, I'd like to quickly add to that we'll effectively invest in an experience which is more first class, which abstracts out even further from a UI perspective. But from an upstream project perspective, we want to ensure that it's well decorated to be able to work well on OpenShift as well as any Kubernetes.
Cool.
Awesome.
Right. So quickly doing a recap of the build we just ran. So we ran an S2I build, and we just did a few typical things with that. We pushed it to an image stream called this, And then while we were talking, what we effectively did is we went and deployed that app using the image stream that we just created. So we just built this image and we deployed it using the OpenShift import flow. Effectively, you can use the image stream that you pushed using Shipwright in OpenShift the usual way you've used images or image streams. No surprises, no unnecessary disruptions there. So with that, I'll summarize and hand it over to Adam to what's next. So to quickly summarize, this brings in a few APIs, but the ones which you primarily should care about are basically the build strategy, build and build run. Build strategy and cluster build strategy, this lets you figure out what's in cluster scope, what's in namespace scope. It gives you that flexibility, and then the rest are to get your builds working. With that, are there any questions on the chat with respect to what we just saw?
I am checking. Let's see. No, not really. I mean,
does this offer anything special in terms of Maven or like a artifact registry? I don't know. I'm not a Java guy.
Does it have a hook in there or anything that we can use?
Right. So there's one thing that we are working on right now, and that's a good question. So one thing that we are working on is that if you are a traditional Java shop and you are effectively pushing artifacts to Nexus and like jar artifacts, and you want to build images out of it, we are working on supporting that as well, which means you don't necessarily have to start from source code. You could start from a jar and convert that into an image. That's a pretty popular use case as well. So we're working on this upstream. Once the proposal goes in, code should show up and support should show up as well.
Cool.
That's pretty cool. So basically, this is going to support the binary builds in an abstract way, let's say.
Yes.
Agnostic way. That's cool.
Right. Like binary builds in a way that, like if there are strategies that do not support that at all, like they do not support that out of the box, that's a different thing. But then it's going to give you a unified API for you to say, hey, I want this binary build with that X strategy. And if the strategy supports it, it'll just work.
Nice.
To add to that, I think there was a question on detections. I think right now, the user has to make a choice on the build strategy because it's more of a conscious choice you're making between Kaneko or Builda or let's say Buildpacks or S2I. But then if those specific strategies have detection mechanism, just like Buildpacks does, it's going to do that on its own.
Cool.
With that,
the last question I saw in here was around concurrency. Is there, like, let's say I was really into running a lot of builds at a time, a small amount of builds.
Or just bursty, right? Like just a bursty build session, right?
Yeah.
Like I could see like 3 a.m. every day, there's a ton of builds that happen kind of thing, right? Or something like that, right?
Yeah, I think so. So right now from an upstream project perspectives, we haven't put those knobs in place to be able to configure that. But then the general recommendation that I give to any vendor who would want to be interested in adopting this, and we have a vendor who's actually adopted this in their beta SaaS already, even though the project is pretty new, is that you can always build those knobs out on your side of the tooling when you're adopting it. And that's been done already. So it's not something that we're recommending, but it's a vague thing. So already there is an adopter called IBM Code Engine who's using this. And
a small adopter,
yes.
IBM Code Engine.
Yeah, I've heard of them. Yeah.
Yeah.
Right. So yeah, I mean, adopters can and vendors can always put those checks in. We just have to figure out how to do it in a good way in upstream so that adopters still have the flexibility to add more to it. And that's a general challenge. We don't want to mess with that.
It's a tough balance. Yeah. That it's always a struggle. Security, usability, right? Like we see it every day. Android users versus iOS users. I mean, it's ubiquitous, right? Like it's an industry thing.
Right.
And I think the purpose of this and I was just going to say briefly, I think the scope and purpose of this seems to be more developer focused and more like how do I get built into the system rather than how do I manage the builds. Maybe that could be done at another layer rather than through this interface particularly. I really liked the simplified, build, run. It reminded me of Tekton, but even more slimmed down, I guess. So it seems like a relatively easy adoption curve for developers who would like to run builds on Kubernetes. So yeah, good stuff.
Correct. Yeah, I mean, this is a specialized, like building images is a specialized use case. So we want to ensure that we do that well and ensure folks are well supported with that. Yeah. So since you mentioned, some of the new capabilities, so just a quick shout out to the audience here. We have the Shipwright project. This is on GitHub. There is an enhancement proposal process, which is effectively tell us why you want something and give us some more details. And the community, which is a growing one, will effectively help you navigate through that and get it accepted and have somebody work on it. It could be you or it could be somebody from the team. So with that, I'll hand it over to Adam so that I don't speak some of the things Adam is planning to speak on. Go ahead, Adam.
I think the only things I want to add, speaking of contributing, there are our future course includes what we kind of mentioned before about the command line interface. We also we Shubik showed you the deployment, installing by our operator hub. We have a script in the repo that you can use to install. We're also working on making this available via Helm chart. So folks don't have to choose how they install Shipwright builds. There's also a docs website. So for folks who are non-coders but have technical writing skills, want to help us out, that website is in progress. And we, in terms of feature sets that we're working on, one of the ones that probably haven't been mentioned, but one that we'll be keen on adopting is integrating with Tekton Triggers. So folks,
nice.
When
So that kind of answers this next question I got for you. From what I've seen, if I want to push a new tag every time I build, I need to create a new build for every tag, a new build run every time. Like that's kind of answering that.
Correct.
Yeah.
Awesome. Cool. With that, quick shout out to the other top contributor. IBM Code Engine, while being a vendor, is also a hot contributor in this project. So yeah, just a quick shout out to those folks if you're in the audience.
Yeah.
Jorge says in chat, will the website support dark mode? If it doesn't, I can't consider this project production ready. Just kidding.
I agree.
That's amazing. That's amazing.
I've been thinking what's missing for a while, and now I get it.
Now you get it. Yeah, dark mode. God. And now there's studies about how like dark mode isn't like the best way to consume content. And it's just like, oh, great. I'm so glad we did this as an industry. Anyways. Thank you both so much. So we've dropped the links to the GitHub repo. Where else can people go to find out more info? Right? Is it just GitHub right now, or do you have like a doc site or anything?
So the doc site is pretty bare right now.
Yeah.
GitHub's probably the best resource. We're working on getting shipwright.io up and running.
I saw that.
On GitHub. I mean, it's way too open to hide that.
Yeah. Getting the whole thing up and running is tougher. Yeah, like open source projects start in GitHub, but like you have to have a website nowadays. You got to have contributing guides. You got to have all kinds of structure and governance and compliance and all this other stuff just to even get going, it feels like. So huge kudos to y'all, and logos, as Brian points out, and dark mode, as Jorge would mention. So like the amount of effort that goes into just starting an open source project nowadays, like if you want people to take it seriously, is very high in my opinion. And y'all are working through it, and you're kind of showing us right now live like what it takes to get something like this up and running, right? Like Jorge's question about like, do I have to do this every time? You know, like y'all are answering that question in a future, build or future release. Sorry, technically a build, I guess. So yeah, the the feature planning looks good. The future looks bright with Shipwright. How about that?
Yeah, and speaking of builds, like one of the things that is, if you look at our issues, one of the issues that's on the project is like ultimately we want to be able to use this to build the thing itself. We want to eat our own dog food.
Yeah, yeah.
And
that sounds amazing.
That is, if we can get to that point where just Travis launches a kind cluster with with Shipwright and Tekton installed, and it builds the Shipwright images and then deploys it on that same one or even a different kind cluster that's running. There's lots of things that
and everything. Yeah.
And
that should work now, to be honest. You just have to get it wired up, I think.
Yeah. Okay.
And
that's cool.
I don't know if folks saw the some of the videos that came out of KubeCon EU. There was a lot of people who were demonstrating how they are using Kind and other tools to do their CI/CD on Kubernetes. There's CDCon actually starts tomorrow. That's the first one. So there's, I don't know if folks here on the stream know about the CD Foundation. It is a sister organization to the CNCF. Their first virtual now conference is going to be tomorrow. It is free. I will be there in the chats. We won't be doing any Shipwright conversation there specifically, but I personally am excited to see what other people are doing with their own CI and CD. Usually on top of Kubernetes.
I botched for some reason. Twitch is botching the CD Foundation link, but whatever. It's there. You can go to CDCon tomorrow. Registration still open, I believe.
Yeah, and it's free. They're raising money for Women Who Code and Black Girls Code, I believe.
Yeah, so like donating your money to the ticket, like it goes to a good cause. You will learn something from that experience, I promise. There's a lot of friends of mine that work in the CD Foundation, right? Like I'm a CNCF ambassador. CD Foundation has their own ambassador program. Like there are friends of mine that have that overlap. They're very brilliant people. You will learn a lot by going to CDCon tomorrow. I promise you that. Ryan, Natalie, anything else you want to share?
Last question. Last question about CNCF. Is there any plan to submit a sandbox project to the CNCF? Or any other plan to submit as any other kind of project?
So there's certainly a goal for the project to submit it to either CNCF or CD Foundation as a sandbox project. There's a lot of work that you need to do to get to that point. As Chris had mentioned. So we're working on that, and we need to come to an agreement as to where we want to land, but ultimately we want this to be in a vendor neutral location and have a good governance structure in place so that it can live on as a full-throated open source project.
And from a technical perspective, right? Like if you're dog fooding yourself, you're there, right? Like once you get to that point, you're ready. It's just dotting all the I's and crossing all the T's to figure out, do you want to go into incubating, the sandbox, or wherever you want to land inside that ecosystem, inside the CNCF, which is a process in and of itself. So if folks have questions, feel free to reach out to me about that. I can answer them offline. I'm looking at the chat real quick. Not seeing anything new pop in, so.
Adam, Shubik, did you all submit anything to KubeCon for this fall?
I don't think we do have anything for KubeCon this fall. But certainly for the next, it probably would be, the next KubeCon would be EU on the calendar, or maybe we.
Yeah, I would like start getting your CFPs dusted off. And y'all let me know. Let me know if you need help with that, by the way.
We actually have a contributor in China, so that is also another option as well.
Right. Although I think they're going virtual next year for that. I could be wrong, but I don't know. I have no idea what's going on these days. Life changes every 5 minutes. So I'm try to keep up.
Or people from the US won't be allowed because we're still banned.
Right. Who knows? Yeah.
Either way.
I
We'll
just
be
live here.
virtual, everyone else will be there. Yeah.
And that's the amazing thing about distributed teams
we were
and
there.
Yes.
contributors, right? That's
So
the
many-
amazing thing.
So many
It's-
postcards. Yeah.
Yeah. So the point is, even if somebody can't travel, there's definitely a contributor in that region who doesn't
Mhm.
have to travel and can't do it. So
Right. Exactly. Yeah. So cool.
And if
awesome.
you're looking to be a contributor in a new region, look us up on GitHub. We'd love to have your feedback. Thanks all for attending today. Thank you to Adam and Shuvik for the excellent demo.
Yeah, that was
thank
dope.
you to Natali for setting up this topic. Yeah, thanks. And thanks to the chat, everyone in chat for all the great questions.
Yeah, as always, thank you
excellent
to
topic
everyone in
today.
chat. Yeah, we couldn't do this without y'all. So please tell your friends and family that OpenShift TV is the thing, and we do this every day for y'all. So please spread the word for us. Coming up
so much
next
for having
is
us.
oh, you're quite welcome. Thank you again
Thank
so
you.
much for having us on,
Thank
or
you.
for you coming on. So up next, OpenShift Commons briefing. We've got my calendar's messed up. Wrong tab. What are we doing next? I'm sorry. I always do this.
OpenShift Commons is here every week following this session.
Following this session,
yeah.
talking about security for Cloud Paks and a Sysflow deep dive. The one and only Kirsten Newcomer from Red Hat will be there, as well as an IBMer. Kirsten is a friend of mine here at Red Hat, and she is a security genius. So please stick around for that. So yeah, thank y'all. We'll catch you next time. And as always, check out OpenShift TV for the latest and greatest. Subscribe to the calendar. And you know what? Give OpenShift a try if you haven't yet. You might actually enjoy some of the experiences we've put together for y'all, including the new assisted installer, which is available at openshift.com/try. So thank you very much for having us, and we'll see you here soon.
Thank you.
Hello and welcome to another OpenShift Commons briefing. Today we have Sridhar Mapidi from IBM, as well as Jose Ortiz from IBM, and Kirsten Newcomer, who is our Red Hat expert in security, and they're here to talk about OpenShift security and Cloud Paks and a deep dive for Sysflow. So take it away, Sridhar. Thank you.
Thanks, Karina. Good afternoon and good day, everybody. Thanks for joining. Today, we're going to talk a little bit about the breadth of what it takes to do security in a hybrid multi-cloud. But like Karina said, we're going to focus on two key topics to get to the level of detail. So thank you, Jose and Kirsten, for joining me in this discussion. So if you move to the next slide, I think security continues to be a key inhibitor for a number of our clients who are moving to cloud on some way, shape, or form, right? We tend to see a couple of different types of requirements. One is coming around the fact that how do we make sure that security is not an inhibitor in terms of running with the pace of the transformation, whether it is trying to modernize an application or lift and shift or combinations thereof. And then the second type of use cases are coming from more of the security persona that is looking at, how do I keep the bad guys out? How do I demonstrate compliance? How do I let the good guys in a manner that doesn't disrupt everybody, right? So if you go to the next slide, you can clearly see the two personas that weigh into security heavily. We call it the shared responsibility. Josh and Jane are our personas. Josh is our quintessential engineer, developer, line of business, architect type of persona that is more closely aligned with the transformation, wants to leverage security for sure, but more focused on the rapid business transformation, right? He wants to ensure that he can get through security capabilities in an automated manner very quickly so that the application he's trying to go live is secure from a compliance perspective, allows people to log in, be able to demonstrate an ongoing compliance, as well as keep the bad guys. Jane, on the other hand, sits in the more predominantly the CISO or the IT side of the business, focused on making sure that the entire enterprise is secure, not just Josh's line of business, but the entire enterprise, right? So she's more interested in making sure that any application which is going out to public is also demonstrating compliance. She doesn't necessarily have all the skills in the team related to the application, but she's trying to ensure and deal with the large volume of applications that are going online, and each one of those has to be appropriately secure. So you can see that it's a shared responsibility. And if you go to the next slide, rather than looking at it as two different types of requirements, it's an integrated process. If you look at DevOps or DevSecOps, and there's a variety of different variations of showing this picture. Some have a lot more details and some have a less details. But the idea that we're trying to show here, if you take a very simple version of the DevSecOps and infuse that with security, we're basically saying that it's not that Josh is developing an application and throwing across the fence for Jane to protect, but it's a continuous integration that needs to work together so that security is throughout the life cycle of DevOps. So if you go to the next slide, you'll see what we mean by that, right? It actually starts with the non-technical side, the people, the process, the culture aspect of it, to say, how do I make sure that we have the discipline to be able to think of security right from the get-go, right? Being able to shift left, not just in tools, but also in thinking. As you're developing an application, as you're planning an application, how do you do a simple threat modeling so that even if you take a very simple application of an application talking to some data store at the back end and hosted on a server, there's a number of different potential entry points for vulnerabilities, right? So how do you accommodate for that? And in some cases, do a good job of coding the application with best practices, in some cases through process and configuration. In other cases, it may be by controls. But it's good to have those upfront so that throughout the rest of the life cycle, you can then start instrumenting security as needed. For example, as we go beyond the planning phase to coding phase, how do you leverage the best practices of secure application development? And you'll see some of that later today as well, right? Providing that automation for testing. All of those are something that the developer community, the line of business community has to think about security tasks that need to be baked in as a part of the DevOps lifecycle, as a part of the CI/CD pipeline, versus trying to look at it as a gate, right? A gate, as you know, tends to be backed up. On the other hand, if you look at it more like guardrails, all along the way, you are cruising, making sure that you're not going beyond the guardrails, but you're keeping up the speed and hence, making your business happy. On the other side, if you look into Jane's world, she's more responsible for the operations, right? Once the application is running, how do I make sure that the right person or the application is coming in for the right set of data under the right conditions? How do you ensure that you're monitoring everything for detecting any anomalous activity, anomalous behavior, and be able to do that on a consistent and a continuous basis so that you're detecting threats accurately, right? We don't have time for a lot of inaccuracies. And then, unfortunately, if a threat does show up, how do you investigate that very quickly, accelerate the investigation, and then automate the response so that you can then go take care of it quickly. A good example could be, hey, I need to go scan a container, and maybe in the process it was not scanned, and or maybe in other ways the malware was installed in a container. That container could be hijacking, or could be hijacking as an account takeover or container takeover. And when you detect it, you may need to drop that, right? Those are some examples of what goes on in at least the world of security people. Now, that's just basically, how we look at, security from two different lenses. Now, from the combined Red Hat and IBM perspective, if you go to the next slide, how do we look at security in a hybrid world, right? We look at client deployments predominantly as hybrid and multi-cloud. That means workloads may be both on-prem as well as in the cloud, and we're not necessarily limited to one cloud, but it could be multiple clouds. Actually working with one of the clients that has segregated the application into different workloads and running workloads where it makes most sense. For example, in Amazon, where the compute is much more efficient than maybe storage that may be more efficient for them to store on-prem or in a private cloud. So that's been our approach, and we do that with a combination of capabilities from Red Hat as well as IBM. And if you look at the right-hand side of this picture, the simple rendition of that, right? We leveraged Red Hat as the underlying fabric for hybrid and multi-cloud that can run in many of the different cloud environments that you see. And we deliver IBM capabilities as what we call Cloud Packs. Cloud Pack for security, Cloud Pack for automation, Cloud Pack for applications. So each of them providing a set of specific business capabilities so that it's all encompassing versus having to piecemeal different capabilities. It simplifies how you want to modernize as well as embark on a journey to cloud. So for example, if you're developing an application, you probably need Cloud Pack for application, and you'll have a number of capabilities in there to help you either to develop or move or enhance an existing application. And you want to do anything with data, you may want Cloud Pack for data, and they all work together. So we live in the world of security. That's where you see the Cloud Pack for security, which is providing that hybrid and multi-cloud security across all of these different cloud environments, across all of these different domains. And the services, which is an important part of providing expertise, sits on top of it. So we focus on three specific areas, right? One is making sure that the security is provided at the infrastructure layer. These are your cloud providers. This is your Red Hat and Fabric at the core that itself needs to be secure to ensure that you can allow for the secure DevOps. You can allow for a secure CI/CD. You can allow for some of the secure processes right from a development point of view. And then comes a set of Cloud Packs on top of it, where we provide security built in to these Cloud Packs, infused into the Cloud Packs, so they are protected at the application level and at the data layer, right? This allows you to ensure that the applications themselves are secure. For example, single sign-on, or being able to do adaptive access, or data activity monitoring, being able to provide capabilities for audits so that you can demonstrate compliance and threat management. All of those kind of fall in the second layer. And the third layer is security across hybrid, which is where we work with the provider. We work with the different layers which encompass a hybrid multi-cloud for a specific client, so that we can then pull all of those different capabilities together into Cloud Pack for security as a mechanism to not just manage your growing threats, but also protect your digital assets like users and applications and data, etc. Right? So that's in a nutshell of how we look at security from a Red Hat and IBM perspective for hybrid and multi-cloud deployments. So today what we're going to do is we will deep dive on two specific topics. So I have my colleague, Kirsten, who's going to focus on the bottom layer from an OpenShift perspective. And then Jose is going to talk about the second layer in terms of an example of how we infuse or instrument security into Cloud Pak or the platform layer so that you're secure by design in many, many cases. So with that, Kirsten.
Sorry, I didn't realize I was on mute. Yes, all set. So as Sridhar said, I'm going to talk about how we build security into OpenShift itself to enable security for the applications and workloads that you might deploy on OpenShift, as well as for the Cloud Paks that IBM is providing on top of OpenShift. So let's just start for a minute by talking about, kind of quickly the value of containers and Kubernetes. I imagine many of you are familiar with these, but I do want to hit them for reasons that you'll see as we keep going. Right, so containers are very popular. I don't know if you just saw my cat go by, but containers have become very popular because they make it so easy to deliver and manage applications by packaging the system dependencies with the application code as well. Right, they're portable across environments, so they support hybrid multi-cloud. And they really appeal to developers for the control that they provide. There's also real value to the ops team as well, because this simplifies the whole process of moving from dev to test to production. It simplifies the deployment process with the dependencies bundled and packaged together. But for managing containers at scale, you do need an orchestration platform. And Kubernetes is the orchestration platform of choice by these days. It provides scaling, resiliency, HA for the application platform, as well as for the cluster itself. All sorts of things there. Next slide, if you would. So Red Hat OpenShift is Kubernetes for the enterprise. We start with Kubernetes and RHEL Core OS as our core set of delivery capabilities, but we build on top of that, because when you think about some of the differences, that model of the dependencies traveling with the application package, this means that you need to build your applications, your containerized apps, in some new ways. It also means you need to patch your applications differently, right? Best practice is never to step into a running container. You always need to be rebuilding and redeploying when patches are involved. And so OpenShift comes with security built in at all layers. We're going to talk more specifically about that in a minute, but also with tooling that developers really need. So that includes Jenkins, if you're using a Jenkins pipeline, Tekton for a next-gen sort of cloud-native pipeline. Code-ready tooling for developers is available with OpenShift. And then a whole bunch of things that support sort of the more cloud-native solutions. So service mesh, Knative for serverless capabilities, and lots of language and runtime support for enabling microservice-based apps, but also for traditional, more traditional architecture apps if you're doing a lift and shift. OpenShift includes monitoring, logging, that can be leveraged by the application as well. So the Prometheus instance, the Elasticsearch, FluentD, and Kibana instance, all of those are available to support the app dev team as well as the ops team. Next slide, please. So when we think about securing the OpenShift platform and container security in general, we kind of think about it in these three major categories, right? It's really important to control application security, and you do that by taking a look at the pipeline and how you manage that pipeline from the beginning of development all the way to deployment. We think about the capabilities, the security capabilities that are needed at the infrastructure layer. And in this slide, the infrastructure is RHEL Core OS and OpenShift together. We think of those as one piece. And so we're looking at the whole platform in that case. And then we also see an ecosystem of security tools that are particularly good at securing containers in Kubernetes or enhancing the built-in security. And Jose and Sridhar will be talking more about one of those tools in the ecosystem. Next slide, please. So as I said, best practice is to rebuild and redeploy any containerized application. So when you think about that, that really means that the CI/CD pipeline for your containers requires more automation than you may be used to if you're working with a traditional app and one that is perhaps not delivered as frequently. So when you're building a containerized image to get those, a containerized app, to get those system dependencies, you're going to include a base OS image, such as the RHEL universal base image. And so if there's a CVE found in those system libraries, it's not in your application code, but it's in those system libraries, you still need to rebuild and redeploy. And so that's why it's so important that we think about all the automation that can be leveraged for a true DevSecOps environment, right? You need to be sure that you've got a trusted code repo. So you, of course, will be pulling content down from external sources, such as for that base image, but it's best practice to have a registry on premises, or it doesn't have to be on premises, but your private registry, to ensure that you're managing all containerized images, all container images before they're deployed. You need to think about ideally automating unit test, code quality, security scans, your integration test, and OpenShift comes with a number of capabilities that can help you there. Code Ready is a set of development tools that, again, are available to leverage with OpenShift. They include IDE plugins that can be used with JetBrains, with Eclipse, with Visual Studio, to help give you information about dependencies and potential security issues right as you're writing your code. Quay with Claire is an enterprise registry, and Claire is the vulnerability scanner for scanning container images. I already mentioned Jenkins and Tekton, two pipeline flavors available to you. You can, of course, use an external pipeline as well, something that's not running on cluster. We also can help you automate, rebuild, and redeploy, leveraging features like source to image, which will make it easy for developers to just write code and automates the process of getting from source code to a container image. Image streams, which will notify you if there are changes to external images that you've included in your custom container. On the production side in particular, you can leverage these capabilities, of course, in dev and test, but on the production side in particular, it's really important to disallow or allow access to specific registries. And again, a best practice is you might, in your dev cluster, allow somebody to download from outside your enterprise, but in your production cluster, really best practice is just to limit access to your private registry. Security context constraints are a native feature of OpenShift. They're a Kubernetes admission controller plugin. They ensure that by default, no container images run with privilege on an OpenShift cluster on worker nodes. A lot of great features built into OpenShift to ensure that not only is the platform secure by design, but to help ensure that the applications deployed on the platform are also secure by design. Next slide, please. So this is just an example about, so security is where we're focused today, but all of this is really about supporting business value, right? And DevOps is about delivering applications faster so that the business value for your customers is available sooner. DevOps is about agility. And we're today talking about DevSecOps, which is always intended, security is always intended to be part of that DevOps pipeline. It's just that sometimes people forget. And so when we take a look at the value that this can provide, right, doing a DevOps approach really does lead to significant value for your organization, such as Schiphol Amsterdam Airport. Right now, they run thousands of containers in mission critical workloads. Those mission critical workloads need to be secured. And they've been able to adopt OpenShift and get a 50% reduction in application development time while maintaining the level of security required for an environment like theirs. Next slide, please. So again, if we come back to kind of that first place where we laid out control application security, defend the infrastructure, and extend with the appropriate tools from the security ecosystem, this is just kind of a one-slide summary of the majority of the capabilities, security capabilities available to you with OpenShift. There's so much to talk about that we really didn't have time to get into everything today. We touched on many of them. But if you, have any interest in following up on any of these capabilities, we do have earlier recorded talks and would be happy to chat with any of you. So, Jose, I think, or Sridhar, back to you.
Thank you, Kirsten. As you can see, very rich set of capabilities, and that's just one part of what constitutes as the infrastructure, right? And if you take this OpenShift and lay it on, let's say, IBM Cloud or Azure or Amazon, you need to think about some of the security capabilities at that level as well, right? So that's what we look at when we say security at the infrastructure level. Now, moving up the stack, as you've heard from me, Cloud Paks provide a mechanism to deliver a business function, right? So what better than instrumenting those Cloud Paks with security so that from a developer perspective, from a business translation perspective, you don't have to worry about too much of these capabilities, but use those built-in features as a mechanism to secure your workloads, especially regulated workloads. Now, there's a number of topics around security, data security, identity and access management, you've got privilege management, threat management. As Kirsten said, there's not much time to go through each and every part of security over here. But what we want to do is double click on threat management, right, in a hybrid multi-cloud. If you look at the next slide, you'll see the typical landscape that a administrator or a SOC analyst has to deal with, especially in a hybrid multi-cloud. You may have events coming from cloud provider, from network security, from your application security, from your on-prem security capabilities, from your potentially, OpenShift that Kirsten was just talking about. All of that need to come together so that you can then provide a mechanism to protect the workloads, be able to detect those threats very accurately, very quickly, and then, unfortunately, if you find something, then be able to investigate and respond quickly as well, right? So we use this as an example today to talk about one project called Sysflow. And the idea that we are trying to build on over here is to say, we want to accelerate the security maturity through open community, right? So this is an open source project with a view to be able to provide that detailed telemetry across a number of different systems. And Jose is going to give a lot more detail on that and show you how you can use it today. Jose?
Hi, good afternoon and good morning. Thank you, Sridhar and Kirsten. So I'm going to touch a little bit of what Sysflow is. And as Sridhar said, it's an open source project. When we started it was focused on looking at the telemetry information and basically, think about it the same way that you will think of NetFlow, as we were looking at raw packages being captured on the network and how they would flow. The teams are looking at files and processes and network access into those files and processes and how they could basically generate a similar notion of a flow by looking at the data and the telemetry. So we started at that in the basic of the system, and then we started looking at how we could apply those topics or that model on the telemetry into containers and other kind of workloads. We also have matured the project and added additional capabilities that I'll touch on a little bit around how we collect the data and then do what the team is calling edge analytics. So the project started as the telemetry portion, how we will capture, how we'll define that information, how we collect the pieces from the operating system, file process data. We started with integration into things, components like sysdic and UEPF, and then we translate that into the telemetry format that we call Sysflow at the moment. I'm going to go into an extension of the project, which is we started the project with this notion of the collector, that we could get information from different sources. So the architecture is there to do that. And then we had a notion of an exporter. So as we collected the data, we processed it, and then we generated the Sysflow telemetry as an Avro format into S3 storage. We also basically have a JSON format that can go into a syslog-like endpoint. But the team added this additional capability that we call the processor that started giving us the ability to do some additional enrichment and processing at the edge, where we might obtain additional information about the system or start getting into other areas like other than looking at the telemetry and doing some analytics to detect the problems, we could potentially start getting into some level of protection, react to those changes locally, or try to prevent those actions in certain cases. So this is kind of a new update that is going to be available fairly soon in the community project, probably end of this month or sometime in the middle of the month. As we said, this is being done in the open. This is just was an internal project that we decided that should also go into the open source project to start augmenting, as I said, the edge telemetry and capability in the system. We have some implementations on the right-hand side. This format is open, so the data can be sent to different implementations on the right-hand side. We have our internal projects to kind of monitor this data, but this left-hand side project is totally done in the open as an open source project. I'm going to go into some of the things that we're doing with the project. As we said, we have the open source project is included as an operator in Operator Hub. So it can be applied or can be installed on any OpenShift environment. One of the things that Sridhar said that we're including in our cloud packs is for our ability to include the telemetry built in and add additional rules into the Sysflow environment that is purposely built for each of the cloud packs. So we can understand application behavior and codify into the rules and provide it into the system. It's the same operator, so while it's included in the common services that you see there for the cloud pack, we're basically sourcing it off the same location. So it's not a double install or anything. We'll detect it and then we'll collect the data. And then we have systems on the far right. Here we have Cloud Pack for security, consuming the Sysflow data and helping the analysts, as Sridhar said, to process information and do their job. So it allows us to connect the applications to the security persona and allow them to do their job end-to-end. I'm going to show a couple of things real quick. As I said, any OpenShift environment has the operator link, so it can be installed from Operator Hub. Right now, this is the community project. It has a 1.1 version. As I said, it's going to be updated sometime in the next few weeks with the additional capability. It's a very lightweight operator. It has one little component that will start sending data. The way to configure it is the operand. You just tell it the endpoint that is going to receive the information. This is one configure for syslog host, IP address, the protocol type, whether it's TCP, IP, UDP, or if it's TLS, and then the IP address. And once it's configured, it will immediately start collecting data. The data in the Sysflow is going to look like this JSON file. When we do object storage, we try to compress it for space. So it's going to be an Avro format that is documented in addition to the JSON format. And we have systems like my session timeout, like QRadar, that can read the information and present it to the user. I'm going to do that. I'm going to go into my 3 days really quickly. And it's going to show the information. In our case, this is one of our systems that we process information. We can show the process data and the raw data as it's coming through to the system. So fairly easy to set up. This particular tool is able to receive Sysflow data and configure it. And we can do additional events analytics on these particular tools that we have here. Sridhar, back to you.
Yeah, thanks, Jose. I think one of the ways that I take away from this Sysflow is, for those of you who are security minded, it's like a poor man's EDR, right? Which is collecting a lot of telemetry from containers, which are the endpoints these days, so that you can, what Jose was showing you is a mechanism of how you would configure it. And what we've done is we put it in Cloud Pak so that every Cloud Pak has that by default. And then on the other side, it could be Cloud Pak or QRadar or Splunk or whatever that can be leveraging that. And then using analytics, you can do attack and some of the misbehavior detection at the workload level, because one of the new thing is more on the behavior side, right? So you can definitely look at that. You can look at some of the forensics, like what happened, get into the threat hunting side. Do some multimodal telemetry, right? It's not just saying, hey, what happened with this file that was sent out or used, but correlate that with the process, correlate that with the network, and then good things might come happen. And all of this is used to not just to catch suspicious activities, but also in some cases demonstrate compliance and enforcement, basically, right? So we're very excited about that, and you can learn more about that in the URLs over here, along with what Kirsten was talking about in terms of the details on OpenShift. So as you can tell, we have these are 2 examples of our overall approach to security, very similar to how we've taken an approach to threat management, being able to instrument something like Sysflow into Cloud Pak. We've taken a similar approach to instrumenting the Cloud Paks with identity and access management, with data security, with some of the audit capabilities, so that you're now able to go and collect this information to go back to my initial point of managing threats better, as well as protecting digital assets like users and data and applications and devices, etc. So one of the things that I want to highlight over here is that by looking at these these 2 layers, right, which is the infrastructure as well as the application platform, we bring it all together with enterprise security, right? That's where IBM security comes into picture, to be able to not just look at let's say Red Hat or IBM capabilities, but also Amazon and Azure and on-prem, etc., and then bring it all together to be able to provide that integrated and automated multi-cloud security management. So sometimes we call it the most secure hybrid cloud because we look at fairly comprehensive across different dimensions and bring it all together into one place with people, process, and technology. So with that, I am going to pause over here to see if there's any questions. We've got about 10, 15 minutes for any questions that we can deep dive into.
Awesome. Thank you so much. That was great. A lot of really good information. And I know that I'm going to be digesting this for a while. We do have a couple questions. So if you could, so first of all, what is the difference between the logging and the audit data that's captured in Openshift versus what's available with Sysflow?
That's a great question. And if I could start and then maybe hand off to Jose for anything he'd like to add. So when you think about it, and I do think it's appropriate maybe also to kind of take a step back and mention kind of the differences between vanilla Kubernetes and a distribution like OpenShift, right? So out of the box, Kubernetes does not come with logging. And there is some audit level capability, but perhaps not everything that folks would want. So to make an enterprise distribution, right, one of the key things we focus on is ensuring that we can meet the typical regulatory and security requirements that an enterprise has. And that includes providing logging and providing audit capabilities for the platform. So by default, OpenShift audits Kubernetes API events. We audit login to the platform. OpenShift includes RBAC by default and integrates with an external identity provider. We also have audit on at the host layer by default using Audit D and RHEL Core OS. And then we include an optional logging stack. Some customers use ours, some customers choose an alternative logging stack. If you were to work with vanilla Kubernetes, of course, which some of you may be doing, you would just need to add your own logging stack there. In OpenShift, the logging stack will capture log data for the platform. All of that is visible to the cluster admin. Application logging data that goes to standard out or standard error is also captured and visible to the application owner, the individuals who have permissions to access that application. And then we have a logging pipeline which collects all of that logging and audit data and makes it simple to push that to the SIEM of your choice. Now, Sysflow goes a level deeper beyond what we collect by default. You can do deeper levels of auditing with the OpenShift audit and Audit D. You can kind of configure those, but Sysflow goes even deeper than that. And Jose, do you want to cover that a little bit?
Sure. So one of the things that Sysflow does is it looks at what file is accessing what process. And instead of being just the system call, so we're getting all the system level events from the kernel level. What file got open, how many writes, reads, and which process did what. So it's looking at all that data. It's simplifying by saying this process have access to this server, to this file, or this network request trigger this process to open this file. It's going to look at that telemetry data, which goes a little bit at the system level, and it's going to tell you on which host, on what container, what process, and it's going to give you that pedigree. Versus, as Christian was saying, the audit and the logs at the Kubernetes level is saying, at the Kubernetes level, what API was requested and who did what when. That's typically for the audit. And for log, it's going to be they opened this file or they did this at a very high level. So determining the full flow of what happened with the particular file and determining the intention if the file was open on purpose by your process or there was an external entity that got into the system and was able to open the files that were not intended to be files. So we start looking at the data in that sense, but looking at millions of events that are happening in the system and trying to compress it to hundreds. so it's more manageable in the system.
Good example, Jose, on the file logging versus Sysflow, right? The actions and the behavior is an important aspect. So as security folks, we are always hungry for more data, hungry for context, right? So the more data that we have, more granular that we have, the more context we have, the better in terms of being able to make that correlation better we can in terms of how we can provide that level of accuracy, right? That's a key thing. So there's always going to be that nuances around that, but every aspect, every layer gives that more granularity for us. Thank you, Karina. Great question.
And we have a follow-up really quick. Somebody's asking in chat, you mentioned that the Sysflow operator would be available for all 6 cloud packs. Can you advise when it will be in the GM version for cloud packs?
So Jose, is that the 4th quarter? Yeah, go ahead, please.
So we're working on putting it in, there's a common layer for cloud packs that we have built that we call common services. We're targeting our 4th quarter delivery to include the Sysflow operator there. And then every cloud pack that consumes that common layer will have access to the Sysflow operator. So it'd be that 3.5. If anything gets delayed, then it's going to be in 1 queue. But right now, we're targeting and working towards a December type timeframe to have the operator included in the cloud packs.
And Jose, you may have mentioned this earlier. Will the operator also be available as an open source operator or community operator?
Yes, so we have think about the project is going to be our upstream project. So we'll have one version that we'll put in Operator Hub for community and work. And then we'll have a version of it that is the one that we're associated with the cloud packs that is included through these common services from an open registry perspective. It'll come down, and then that one that is has better, some is a downstream version will also be included in a way that you can get it directly to Openshift. So we're going to have the downstream version available for both straight into Openshift and to the cloud packs. And then the community is our upstream that will continue to update, and that typically will be to Operator Hub.
Terrific.
Awesome, thanks. Switching gears a little bit, there's a question around SCCs and PSPs. For those of you who aren't sure what those are, SCCs are security context constraints in OpenShift, and PSPs are pod security policies. So what is the difference between SCCs and PSPs? Kirsten?
Sure. Yeah, and just for anybody who who needs a little bit more background, so both of these are Kubernetes admission control plugins. So OpenShift has had security context constraints since 3.0, which maps to Kubernetes 1.0, simply because our customers needed ways to really tighten the security and manage kind of in a very declarative way the security of pods that are deployed on the cluster. So any pod can request certain privilege as part of what's called a security context. It's part of the metadata associated with the pod. And the admission controllers, either security context constraints or pod security policies, which is the vanilla Kubernetes version that was Red Hat contributed SCC code upstream, which led to the creation of pod security policies. Both of those features, when enabled on a Kubernetes cluster, allow the administrator to ensure that if a pod requests access to privileges that the administrator does not want to allow, that pod will not be allowed onto the cluster, right? It will simply be rejected. So again, these are both plugins to the Kubernetes admission controller. If you're familiar at all with the Center for Internet Security Kubernetes benchmarks, the CIS-Kube benchmark recommends turning on PSPs, since that's what's available upstream. SCCs have a few more capabilities than PSPs do upstream. PSPs are still beta in upstream, and the upstream community is still debating whether that's the implementation they want to proceed with, or really there's starting to be some momentum building around OPA Gatekeeper as an alternative approach to do that same sort of thing, to gate admission based on policies that are managed by the administrator. So we'll see how that evolves and where that goes, but in the near term, both of those are available to you to kind of really help ensure that the cluster kind of is designed for security out of the box, that designed with security built in.
Thank you, Kirsten. So Sridhar and Jose, how are you using SCCs and PSPs in Cloud Pak for security or across all the Cloud Paks? I don't know if you want to.
That's a good question. So as part of the IBM process, and when we build our container software, one of the things that we have as a process is something we call security by design. So we go through the same DevOps process that Sridhar was talking about, our plan, our design, and so forth. And one of the areas that we include as part of looking at our containers is how are we going to run them in Kubernetes? So we look at recommendation based on customer feedback, and we have recommended our teams to look at specific SCCs for most of our components. We recommend that people use the restricted SCCs provided by Red Hat because that's going to give us the bigger deployment capability across customers. And then based on that, we start looking at what are the capabilities that might need to be defined within a particular container deployment and what additional security context needs to define for that deployment. So as a practice, we look at very end-to-end aspects of the life cycle of the container and what we're going to be allowed. So by practice, we try to be unrestricted. The next one that we look at is NAUID. So those are the typical ones, unless we start talking about components that are monitoring or that are databases that need further access into the system. So those are going to go into some of the other SCCs or security policies that allow us to look at IPC calls or other things like that. But for the most part, most of our containers are restricted or NAUID. NAUID is a special restricted one that allows you to, when you deploy the environment, get a particular ID, so you're not running as root. The system gives you your ID, and then you're acting as that user in the system. So that's our best practice for our software. And then we try to document that for our end users, especially in the database case, because our customers, when they're deploying and managing the environment, they have certain practices that they themselves say as an administrator what kind of security contexts are configured. So databases and things like that need more access, so they need to know so they can prepare those namespaces for that access.
Right, and Jose's exactly right that things like logging in particular, right, you need to be able to scrape endpoints and things like that. So absolutely makes total sense the way the team is laying out the different perspectives based on the capability required for the solution. Following least privilege, right? Least privilege whenever possible, and only adding privilege where needed.
So you also mentioned that, so Sridhar, you mentioned that, security is hungry for data, right? That makes it also sound like, you're increasing your footprint, but I know you don't want to really do that. So what are you doing to address the amount of data that you need?
I think a couple of things, right? First and foremost, I think if you look at what Jose was talking about as part of Sysflow, we've introduced a lot of compression with the mechanism to not just flood the gates, but being able to take the relevant data so that we can do the appropriate analytics, right? Second is, a lot of analytics on the edge itself, right? Trying to ensure that, if you can do a compute on the edge, you do want to do the compute. A good example is, things that we use for behavioral biometrics, especially as, how you hold your device or how you move your mouse and use the keyboard. We don't necessarily, send everything to the mothership to calculate and come back, right? How do you compute some of that with local resources as much as possible, right? And the other part is fundamentally as an approach, we are not necessarily saying that, all the data should come to one place. That's what we're trying to say. In many cases, most of these hybrid deployments, data can be left where it belongs. And we bet on a couple of other industry open standards as well as open source projects, which I'd love to give an update to this team and community, called Open Cybersecurity Alliance. And the whole idea of that is we have leveraged some open standards like STIX and others to keep the data where it belongs, but do the normalization upfront so that as you're doing things like a search across a number of different products, we're not necessarily bringing the data in, but running the analytics and the search on federated approach, basically, right? So it helps in terms of reducing the data movement. It helps in terms of distributing the compute load. To Kirsten's point, need to know basis, right? Why carry all the data into one place and get into data residency issues when you don't have to? So those are some examples, Karina, that come to my mind in terms of not exploding the proverbial data lake. So.
Thank you. Now, if we can do a quick shift back to you, Kirsten, we have a question around Openshift and security. So you mentioned that our cause is treated as part of the Openshift platform. What's the security value that offers?
Sure. So one of the challenges, again, if you're looking through the full stack, think about kind of the graphic that Sridhar shared earlier about we've got you've got the cloud platforms, you've got to manage the security for those, you've got the host, the VMs that maybe are deployed on those, you've got the host operating system, you've got Kubernetes, you have all of the things that you need to add to Kubernetes to ensure that Kube is secure, and then you have the workloads running on top of it, and those workloads need some additional services sometimes, such as the things that Sridhar was talking about, and such as Sysflow. And so what we've done with Openshift 4, we found that with Openshift 3, those layers were managed separately, right? The host operating system and Openshift itself. We've always tested our integrated RBAC, our logging stack, monitoring, metering, all of those things we've tested together, our pipelines. But the host OS was delivered and managed separately. Now with Openshift 4, we're using RHEL Core OS as a container optimized operating system. It's got a reduced attack surface, and we are managing it as part of the Openshift cluster. You might think of it like an appliance. And we're actually able to do that through the use of Kubernetes operators, so that we are using the Kubernetes declarative paradigm to manage Openshift Kubernetes cluster itself and the underlying host OS. And so we use a machine config operator to ensure that every node has the same configuration for the host OS. It's an opinionated, it just has what's needed to support Openshift. If you need to do something like add a GPU device driver, you can do that. There's a way to manage all of that. But the machine config operator can also do things like monitor for configuration drift. If there's an unsupported config change made, even at the host OS level, Openshift will deprecate that node. And again, Sridhar, you were talking about sometimes the security team wants to take a pod out of service. Well, sometimes you might need to take a node out of service. Right. And so Openshift makes it much easier to track everything as a holistic set, right? Your whole platform all the way through.
Thank you. That was great. And we'd love to have all of you back again for some more deep dives. Are there any closing thoughts with our last few minutes?
Yeah, I'd love to, have the opportunity to discuss Open Cybersecurity Alliance. This is, we in security is a very, very, very fragmented space, right? Number of different capabilities that need to come together to be able to address and solve some outcomes like, being able to detect insider risk or be able to detect a fraudulent user. And all of these capabilities have to come together, and sometimes it becomes the onus on the clients to pull all these integration things together, right? So the approach that we've been taking is to say, how do we come together as an industry and do a better job of sharing information, right? Our adversaries, our threat actors are doing a great job, right? We as threat defenders should do a better job, or if not as good a job of sharing information and capabilities so that we can keep up with the growing threat landscape. And thank you for the opportunity here, Karina.
Thank you so much. And thank you everybody for joining us for another OpenShift Commons. And next Tuesday, we will have we're going to be talking about integration at Red Hat. So join us then. And thank you again, Sridhar, Jose, and Kirsten for joining us on this OpenShift Commons. Thank you, and Chris.
Thank you.
Thanks all.
Thank you. Have a nice day.
Bye-bye.